Now we will use those trig ratios above to find missing side lengths. So notice down below in questions A and B number 3, we're finding missing side lengths correct to 2 decimal places. So we have a specific rounding rule. So using this first triangle, what I always do is I start by circling the acute angle that I know, if I know one. So circle the angle. I know 20 degrees. Then I always label the hypotenuse first. The hypotenuse is the right angle. You can turn into an arrow. It's pointing at the hypotenuse. So I'm going to put an H there. Then I decide opposite and adjacent. So in reference to this angle here, I have opposite and adjacent. There. Let's see if I can get that to work. There we go. All right. So if we want to find x first, well, I'm going to use the 20 degrees. It's a smart idea to use the 4 because I know the 4, which is hypotenuse. And then x is the adjacent side. So I want to look above. What trig ratio uses adjacent and hypotenuse? Which one uses adjacent and hypotenuse? And that's cosine. So remember, we know cosine of the angle is equal to adjacent over hypotenuse. So if I use that ratio, I have cosine of 20 degrees is equal to adjacent over hypotenuse. So the adjacent side is x over the hypotenuse, which is 4. Okay. You can use NSolve in the calculator if you'd like to find this. If you want to solve it algebraically, it's quite easy to solve algebraically as well. Please make sure your calculator, notice up here, mine says rad up in the top right corner. I'm going to click that so that it says degrees. In this class, you should always be in degrees, so make sure yours says degree there. You're going to go to NSolve. Remember, you can go menu, algebra, numerical solve. So we're going to go to NSolve. On the left, you can see I just pressed the trig button. So I'm going to go cosine of 20 equals x over 4, comma x. So I have the cosine of 20 equals x over 4, and I should see x is 3.76 to 2 decimal places. So I have 3.76 centimeters. It's less than the hypotenuse, which is a good sign. Okay, now I can find y. To find y, I think I would also use that 4 hypotenuse. So if I use the 4 hypotenuse and the opposite, I could use the 3.76, but remember that's a rounded number, and it's going to be complicated to try to use the 3.76. I'd rather use what's already given to me, which is the 4 and the 20. And then the opposite is y. So what trig ratio uses opposite and hypotenuse? That would be your sine ratio. So I have sine of the angle, sine of 20 degrees is equal to opposite over hypotenuse. Opposite over hypotenuse is y over 4. And then you can NSolve that as well. And let's see what we get. I'm going to be a little bit lazy, and I'm just going to replace cosine with sine. Sure, you can put a y here if you want, but then I tell the calculator to solve for y. You could have kept x, it doesn't matter. I get 1.37 for y centimeters. Great. Okay, I encourage you to try the next one on your own, but I'll go through it with you as well. If you want to watch, you can. So I'm going to, part B, I'm going to circle the angle, 15 degrees. Remember, circle the angle, label the hypotenuse, which is y. The right angle points at the hypotenuse. And then the 2 centimeters, in reference to this angle here, the 2 is opposite or across from it. It's not adjacent. Oh, the cat's walking on the computer. Oh, sorry. Okay, there we go. Opposite here. Okay, and so this side here, I don't know, and I don't want to know, and so I'm not even going to label it. It's not something I need to know or something that I'm already given. So I'm going to see which trig ratio uses opposite and hypotenuse. That's still sine. So I have sine of the angle equals opposite over hypotenuse. Opposite over hypotenuse is 2 over y. And I can end solve that. Sine of 15 equals 2 over y. So sine of 15 equals 2 over y. Sine of 15 equals 2 over y, and I get y is 7.73 to 2 decimal places. Y equals 7.73. The units are centimeters here.